Hey there, in this video we are going to look at multiplying multi-term radical expressions. In other words, multiplying radical expressions that have more than one term in them. Alright, so multiplying multi-term radicals. We'll start with a situation where one of the two things we're working with has more than one term, and then the other one just has a single term. It's important to recognize the difference here. This is 5 root 7. This is 2 minus root 3. This one has two terms. This one has only one term. Critical to notice that minus in there. If we're going to multiply this out, we need to think about exactly the same as what you would do if you had something like 5x times 2 minus y. And think about what you would do with that. Well, what you would do with that is you'd say it's 5x times 2, and then 5x times y. So we're going to do exactly the same thing here. We're going to do 5 root 7 times 2 first, and that's going to give us 10 root 7. And then we're going to do 5 root 7 times minus root 3, and that's going to give us minus 5 root 21. Now we should look at that before saying that this is our final simplest form answer. We should look at the two radicals to see if there's any way we can simplify either of those. Root 7 doesn't have any numbers that are perfect square factors. We can't do anything with that, nor does root 21. So because that's true, that's the simplest form you can do that. Before moving on here, it's important to recognize you can't then try to do anything with this, like 10 minus 5 is 5, and root 7 minus 21. There's no way to simplify that anymore, because these are not like terms and you can't simplify them to make them like terms. All right, let's look at this next one here. This also has a single term times two terms here, so we'll do the same thing. We'll multiply that times this term first. We're going to have 20 root 15, and then we'll do this term times the second term, 2 root 3 times root 3. You might feel like you want to write 2 root 9, which you can do if you want. It's probably a good habit to get into to recognize, though, if you're multiplying root 3 times root 3, just write it as 3, because that's what it is. Root 3 times root 3 is 3. All right? Whichever way you do it, you end up with 2 times 3 here, which is going to be a 6. And then 20 root 15, there's nothing we can do with this root 15 because it doesn't have any perfect square factors. So that means that that is our final answer there. Next thing we're looking at here has two things that each have two terms. Now, anytime you've multiplied things that have two terms before, just think about what would I do if it said 3 plus x times 2 minus y. Well, you'd have 4 terms there. You'd have to do 3 times 2, 3 times y, x times 2, x times y. And you'd have all 4 of those terms. You're going to do exactly the same thing here. You're going to first say 3 times 2 is 6. You're going to say 3 times minus root 7 is minus 3 root 7. You're then going to say root 5 times 2 is plus 2 root 5. And you're going to say that root 5 times minus root 7 is minus root 35. You have 4 terms in your answer. None of them are alike. You can't add any of them together right now. And looking at these 3 radicals, none of those have perfect square factors. You can't simplify any of those. So that's the simplest you can make your answer. It doesn't look like it's any shorter than what you started with, but it's at least a single thing. There's no multiplication left to do. All right, let's look at a few more. Now, we'll start with this one before tackling this, which looks fairly complicated. This also has 2 terms times 2 terms here. But the difference is that some of these numbers look the same between the two of them. So you're going to see that that has an effect on what happens once you multiply it out. Now, just like before, we're going to do each of these times each of the terms over there. We'll start with those two. 2 root 3 times root 3. That's something we had up above. 2 is 2 times root 9, or in other words, 2 times 3. We're going to do that one times the second one here. 2 root 3 times minus 5 root 6 is minus 10 root 18. And then we need to do this second one in this first binomial times this, root 6 times root 3. That gives us minus root 18. And then the last pair there, minus root 6 times minus 5 root 6 is plus, because it's minus times minus, 5 times 6, right? Or root 36 if you want. Root 6 times root 6, you can write root 36 or just directly write it as 6 right away. 2 times 3 is going to be 6. We have minus 10 root 18 minus 1 root 18. That is going to give us minus 11 root 18. And then plus 5 times 6 is going to give us plus 30. The 6 and the plus 30, we can put that together and make this 36. The last thing we have to look at here is this minus 11 root 18. We need to look at if we can simplify that. Because root 18 does have a perfect square factor. You can actually write it as root of 9 times 2. When you write it as root 9 times 2, that means we're going to have minus 11 times 3 times root 2. And then, of course, we have our 36 in the front there. And that means we can write it as 36 minus 33 root 2. That's as simple as it's going to get. We can't make it any more simple than that. I know it looks tempting probably to say 36 minus 33 is something, but they're not like terms. All right? Now let's quickly make some space here. Okay, last thing we're going to look at here is this one involving cube roots. Same concept though, single term times something with 3. So we're going to have 3 terms in our answer here. If we do this first pair, cube root 6x times cube root 2x to the 4th. We're just going to write it first as cube root of 12x to the 5th. Second thing here, we have cube root of 6x times 5 cube root 4x squared. So we're going to have 5 outside. Cube root of 24x to the 3rd. And then the last one there is going to give us 2 cube root 9 times 6 is 54, and we have an x. Now, that's equivalent where it's multiplied out, but again, as always, we're going to look to see if we can simplify anything. We're looking at cube roots, so we're looking for perfect cube factors here. 12 doesn't have a perfect cube factor. X to the 5th does, though. You can write it as x cubed, and then times 12x squared. If you do that, the x cubed can be written as x outside of that expression, and then 12x squared is what's left inside of there. The second one here, 24x cubed. Well, x cubed is a perfect cube, of course, and 24 can be written as cube root of, we can make this 8. We'll put the 8x cubed there. The 24 I'm going to write as 8 and a 3. Because then we can write this as 5 times cube root of 8x cubed is 2x. And the leftover part here is cube root of 3. There's only a 3 left inside there. And then the last thing, we can look for a perfect cubed here. X is not a perfect cube, so we can't do anything with that. And 54 does have a perfect cube factor. It is 27. So we can write this as 2 cube root 27 times 2x. And the 27 we can then write cube root of 27 is 3, and then we can leave cube root of 2x over there. So when it's all put together here, we can have x cube root 12x squared plus this stuff together. You can make it 10x instead of 5 times 2x times cube root of 3, and then minus, we can make this into a 6 times cube root of 2x. All right, so that was a bit of work, but that is the simplest way to write the product of those two things. All right, so that is multiplying multi-term radicals.